Hello students, this is Dr. Ben, and here we have a problem out of Chapter 6 that has to do with the concept of conservation of energy. So we have a high jumper, and we're asked to consider the motion of jumping. We're told that during the jump, his center of gravity rises by a certain amount, and we want to figure out how fast the jumper needs to be going in order to make his center of gravity rise by that amount. So in this problem, we want to use the notion of energy transformation, and so actually in the original situation we have kinetic energy, and in the final situation we have gravitational energy because the high jumper's center of mass is above the ground. So we want to use the conservation of energy, and we'll say that the mechanical energy that the high jumper has in the original situation is equal to the mechanical energy that the high jumper has in the final situation. And in the initial case, there is only going to be kinetic, and in the final situation, there's only going to be gravitational. And we just have to use the appropriate formulas for those two types of energy in order to figure out what our answer is. So the kinetic energy is given by the expression 1/2 mv original squared in our case, and the gravitational energy would be mg multiplied by the change in the vertical position, that would be h. And so if we solve this expression for the original velocity, v original squared, we'll multiply by 2. The m's cancel out, so that'll be 2gh. There we go. And take the square root of both sides. V original is equal to the square root of 2g times h. Alright, so we'll get our calculator out, and for this problem, h is equal to 1.2 meters, multiplied 9.8, which is g, multiplied by 2. We'll take the square root of that, and we get 4.8. 4.8, and that will be meters per second. So that's going to be the speed that the high jumper needs to have in order to leave the ground in order to raise his center of mass by 1.2 meters.